Hey there, year 11s. In this next example, we are now going to look at applying function notation. Again, I would encourage you to use your CAS. I'm just going to make a new page just to start my new page. But here we go. Let's start. So they say if you have a function, right, f, where the domain is any number that you can have and the function is clearly a linear equation, they say that f of 1 equals 7. What they're trying to say there is when x equals 1, the y value is 7. That's essentially what it is. You're subbing 1 into there, and then f of 1 gives you a result of 7. That's how you read the function notation, right? So that's the first part. And then the second one, essentially they're saying when x equals 5, the y value equals 19. That's what they're trying to say. Okay? Find a and b and sketch the graph. Well, that's pretty straightforward because you're given two coordinates and two unknowns, a and b. You can find that using simultaneous equations. So you can again sub when x equals to 1, y equals 7. So then your f of 1, that was meant to equal 7. Well, f of 1 means that it's a times 1 plus b. That's what f of 1 is. And that's meant to equal to 7. So simplifying that, that gives me a plus b equals 7, and that's my first equation. Equation 1. And then you can do the same thing. We can then say sub the next point, which is when x is 5, y is 19. So that tells me that I should then have f of 5 is meant to equal to 19. Right, but f of 5 is just simply sub 5 in where the x is, plus b, and that's meant to equal to 19. So that essentially gives me my second equation, 5a plus b is equal to 19. There we go, here's my second equation. Your job is to solve this a and b with those two equations. So going back to year 9 mathematics, I'm going to use process of elimination method, and I would probably do equation 2 minus equation 1. Using elimination method. So I'm saying 5a plus b is equal to 19, and then 1 is a plus b is equal to 7. Using process of elimination method, 5a take away a is 4a, b take away b is 0, and then 19 take away 7 is 12. Okay, so that simplifies down to 4a equals 12. Therefore, a divide both sides by 4 equals to 3. Okay, so now that I know a equals to 3, well, that means b, sub it back into any of the equations, either number 1 or number 2. So sub a equals 3 into number 1. Then you would get 3 plus b equals 7. Therefore, b must equal to 4. True? There you go. So I've got a and b, and now they want me to sketch that equation. So what's my equation? My equation is y is equal, sorry, not y, it was function. Function was any real number mapped onto the codomain, which is R, and the function is equal to a, which was 3, so 3x plus 4. There you go, and if we were to sketch this, so here we go, I'm going to use my axes. Let's sketch it very briefly. Whoops. Here we go. Oh, what happened there? Okay, so that's my axes there, and 3x plus 4, it's a straight line, it's a linear equation, so I would then say y-intercept is clearly at 4, so 0, 4, and the x-intercept, I can do it in my head here, let f of x equal to 0, so then you get negative 4 on 3, so say about here, negative 4 on 3, 0, and then use my ruler. Okay, make sure to use a ruler when you're doing straight lines. And I can sketch it infinitely because they said the domain is all real values. Okay, so that's my y-axis, my x-axis, and that's my graph. So that's how you would do it. But you can see it's pretty much the same thing as normal. It's just you're trying to apply function notation. Okay.